Okay, welcome to the NUPOC Video Study Guide number 40. Let's look at the second part of question 2 in the differential calc section excuse me, of Guide 1, which just asks us to use the chain rule in differentiation. Alright, so let's go ahead and just take a look at a couple examples. So let's look at like d dt, let's look at a trig function, right? Something simple, sine 3t, or something like that. Or we could just say sine omega t, whatever. So the chain rule just basically is telling us that when we have some function of our independent variable that's sort of inside of another function, we need to differentiate with respect to the outer function first, and then multiply that by the derivative of the inner function. So, for example, if you look up in some table, if you looked up, say, d dt, right, sine u, right? Now if this was d du sine u, then it would just be cosine u. But if it was d dt sine u, right, then the table would probably say something like cosine u and then u prime times u prime, which is just du dt, right? So it's sort of like differentiating with respect, differentiating the outer function with respect to the inner function, right, times the excuse me, the inner function with respect to the actual independent variable. So this would actually be like saying d dt, this right here, this is d du, or d dt sine of u, where u is just some function of t, right? So here we would say this is, let's say, so d sine of 3t, derivative with respect to 3t, right? Because this right here, this is just d sine of u du, right? Or u is our inner function here, times d 3t dt. And then you can sort of look at it almost like a conversion factor, where this differential operator here cancels with this differential down here, and so we're left with just d sine 3t dt, right, which is what we want in the first place. So we know this derivative here is just cosine 3t, and this derivative is 3, so times 3. So this would equal 3 cosine 3t, instead of just cosine 3t, which is sort of what the what's the sort of the suspicion, or what you would be tempted to do if you're doing it quickly, right? And so when we integrate, we'll bring out a 1/3 here if we integrated it, and so we would go to 1/3 times 3 sine 3t, and so we would get back, if we integrated this function, we get back to sine 3t. Let's just do a polynomial example real quick. So if we did, so we'll call this like example 1 and example 2 maybe, right? So let's look at, say, d dx of 5x plus 1 to the third or something. And of course you could just multiply this out and then apply the differential operator to each term individually, but again, this will be this is sort of like our u, right? So first we have to do d of the whole function du, okay, and then du dt. So let's let u equal 5x plus 1, right? So our chain rule is going to say, let's look at d of our function, d of f of x, du times du dt, right? It's sort of a way to think about it, and then this du goes away to get a derivative of our function with respect to t. Excuse me, x. So we're using x in this course. See here we've got our function of x and then dx, right? So here that would be d 5x plus 1 to the third d 5x plus 1, right, times du dx, so that's just d 5x plus 1, right, dx. And so this just equals, we know that this here, this is 5x plus 1, all right, times 3, bringing down this power here, and then squared. And then this here, this is just 5, right? So what we have is d dx 5x plus 1 cubed equals 15, right? 5x plus 1 squared, right? So this term comes from the chain rule, and then I'll just kind of write this answer off to the side here as a sine of 3t or omega t or whatever equals 3 cosine 3t, where the 3, like I just said, could be an omega or whatever variable, right? So, and this factor again is from the chain rule. So there you go. When you have some sort of function that has sort of an inner part to the function, and then there's sort of an outer function sort of around that, you just kind of want to chain it out using this sort of form here, right? You could assign the inner function some variable u, but basically the point is you take the derivative of the whole outer function with respect to the inner function, and then the inner function with respect to your independent variable.